Dear students, today we will discuss on the numerical problems by using Ohm's law and Kirchhoff's laws. Until now, we have seen about the fundamentals of electrical circuits. That what is a node or a junction. So, for example, if there are two elements connected together, that forms a node, and if there is a third element or there may be a fourth element like this forms a junction. So it is the point at which two or more or three or more elements connected together. And branch means what? It is the elements connected between two nodes. If there are two nodes, let us say n1 and n2, and the elements connected between them form a branch. Let us say there are two resistors R1 and R2. Then loop and mesh. If, for example, we have an electrical circuit like this, loop or mesh is a closed path. So mesh is a closed path where within which you cannot find another closed path. For example, this battery, this resistor, and this resistor forms one closed path, and within which there is no other one. Therefore, this forms a mesh. Similarly, this is one mesh. Okay, but this can be called as a loop because in this loop there can be one or more meshes. Okay, uh, that is the one. Next, network elements, the elements that are present in the electrical circuit, the passive elements are given by what? Resistor, inductor, capacitor. Then the active elements are nothing but voltage source and current source. Then Kirchhoff's laws, we have seen two Kirchhoff's laws. One is Kirchhoff's current law and the Kirchhoff voltage law. Kirchhoff current law is applied at the junction so that the currents equations can be obtained. If I1 is the current entering into the node and I2 and I3 are coming out, then we can say that I1 incoming current is equal to outgoing current I2 plus I3. So Kirchhoff current law says that algebraic sum of currents at a node is zero, or sum of incoming currents is equal to the total outgoing currents. KVL is what? It is the algebraic sum of the voltage drops and EMFs around a mesh or a closed path is zero. So if, for example, I start from this point, move like this. Here there is a voltage rise. So this is voltage V1, let us say, and this is voltage V2, and here this is voltage V3. So there is a voltage rise V1, there is a voltage drop V2, there is a voltage drop V3. So V1 minus V2 minus V3 should be equal to 0, because fine, if you travel all through these voltages, you will come to the original point. So there is no potential difference between the start point and the end point, and hence V1 minus V2 minus V3 is equal to 0. So this is what we have understood, and based on these ideas, we will try to solve some numerical problems. So by the end of this session, we should be able to determine branch current, voltage, power of DC circuits using the Ohm's law and Kirchhoff's laws. So consider this circuit. Use Kirchhoff's voltage law to find the voltage VAB in the given figure. So where is VAB? This one. This is A and this is B. What is the voltage between these 2 points? So we can also represent like this. Okay. This is VAB. This VAB I want. So we shall use what? As I want voltage across the resistor and there is a closed path formed, we can now find the, sorry, okay, in the given question, this is VAB. This is terminal A, terminal B. So this voltage you have to find. Okay, this voltage you have to find. So here there is a wire, that's all. Here there is a wire. So as it is shorted, B and C are directly connected through a wire. B and this capital C are same. Similarly, this A and capital B are same. So I can write here VAB is equal to this voltage VAB is nothing but A is nothing but B, and this B is nothing but C is nothing but VBC. Okay, now we can find that. So first you can rewrite this circuit like this now. So here we have 24 volts, Here it is 2 kilo ohms means 2000 ohms, and this 1 kilo ohm means 1000 ohms. This is 3 kilo ohms, 3000 ohms like this. So this is VAB, okay, or B capital BC. So now we can see here there is only one closed path. There is only one closed path. So current flows like this. Now I can find what is the current here. The current in any circuit is equal to total voltage and the total resistance of the circuit. What is the total voltage here? 24 volts. Between this, how many resistors are connected? 3. So 2000 plus 1000, 3000, 3000 plus 3000, 6000. So total resistance of this path is 6000 ohms. So that's what here, 6000 ohms, and hence current will be equal to what? What will be the current that flows here? I will be equal to total voltage 24 divided by 6000. So if you calculate that, you will get 4 milliamperes. 4 milliamperes. Now what is asked here? We have to find voltage VAB. What we have found? We have found current. This current we have found, but I want this voltage. So if you see here in the loop A B C D A B C D A, in this path if you see, okay, this voltage I want. This voltage is nothing but what? You can apply KVL now. You can apply KVL. So if from here to here, if I move, it is voltage rise 24. Here there is voltage drop. So I into 2 kilo ohms is the voltage here. Current into resistance is voltage. And what is this voltage? This voltage is nothing but VAB. So I can write KVL equation in this closed path as 24 minus I into 2000 minus VAB equal to 0. So this is voltage rise. These two are voltage drops. So we have calculated 4 milliamperes, and now substitute the value and find VAB. So solving you will get VAB as 16 volts. VAB as 16 volts. So let us see another circuit. For the circuit shown in figure, find the currents flowing in all branches. Find out what is I1. This in this branch, what is I2? What is, so if you find I1, I2, if let us say this is I3, this is nothing but I1 plus I2. Okay. You can see here, if this battery is giving current I1, if this battery is giving current I2, I1 and I2 are joining and I1 plus I2 will flow. This battery can take current also. As these two are at high voltages, this is low voltage, current will flow like this. So I1 plus I2 will flow like this, and I1 plus I2 will flow like this. When I1 plus I2 is coming like this, I2 will go in this path, and remaining current I1 will continue like this. So this is I1, and this will be I2. Okay. So now we can write a KVL. Applying a KVL to the loop A, B, C, F, A, B, C, F, A. Okay. Whenever you have more than one loop or one mesh like this, write down the KVL equations for the two meshes separately. So now for this mesh, if I write what I will get here, 30 minus 2I1 minus 10. Okay, then here current is flowing upwards, so this will be plus and this will be minus. So minus 10 plus 5 into I2 equal to 0, plus 5 into I2 equal to, you see this equation, 30 minus 2 into I1 minus 10 plus 5 into I2 equal to 0. So you get this equation, 2I1 minus 5I2 equal to 0. Similarly in this loop, you try, you're moving like this, plus to minus. So minus 5 into I2 plus 10 minus 3 into I1 plus I2 minus 5 minus 4 into I1 plus I2 equal to 0. So rearrange it, you'll get 7I1 plus 12I2 equal to 5. Now using this equation 1 and 2, you solve for the variables I1 and I2, the currents, the branch currents. So solving, you are getting I2 as minus 2.2 amps and I1 as minus 4.5 amps. So from that you can find the what is the current in this part, which is I1 plus I2. That comes to 2.3 amps. So next one, in the following circuits, find the unknowns. What is that unknown? Here voltage is given 120 volts, resistance is 100 ohms, and what is the current? Yeah, what is the current here? I you have to find. See, current is flowing like this. Current is flowing like this. This is plus. So battery plus is here, battery minus is here. Current comes from the positive terminal. So current flows like this. Current flows like. When the current flows like this, uh, now you can see here ammeter is nothing but a measuring instrument. It acts as short. It is nothing but a wire you can assume. So what is happening? This voltage is directly applied across the resistor. So V by R will give the current. That's all. So 120 divided by 100, that is 1.2 amperes. That is the current. Now if you want to convert into milliamperes, because it is given in milliamps now, if you want to convert into milliamps, multiply by 1000. That comes to 1200 milliamperes. Next, what is asked here? A 24 volts is applied across an LED. Current flowing is 600 milliamps. What will be the resistor? This is all Ohm's law. V is equal to I into R. Okay, now I want R. R is equal to what? V divided by I. That's all. So R is equal to V by I. 24 divided by 0.6. 600 milliamperes is there, which is equal to 0.6 amperes. So that comes to 40 ohms. 40 ohms. Yeah. Students, we have seen some of the problems, numerical problems, to find the current voltages like this by using Ohm's law and Kirchhoff's laws. So you can try to solve this problem. So there is a branch connected between A and B with elements 3 ohms, 2 volts, and 1 ohm. What you have to find is VA minus VB. VA minus VB is nothing but what? Voltage between these two nodes, which is equal to VAB. Okay, you have to find what is this value. So if you move from like this, current is flowing like this. So this is plus, this is minus. You'll get minus 2 into 3, then minus 2, minus same current will flow because all are series connected. Minus 2 into 1. Okay, now we'll get what? VAB is equal to minus 3 into 2 minus 2 minus 2 into 1 equal to minus 6 minus 2 minus 2 equal to minus 10 volts. Yeah. Similarly, now solve this one. The potential difference between A and B, VA minus VB, had to find. So this voltage you have to find. So the only thing is same, dotted lines are given, that's all. Which is nothing but the battery, resistor connected. So answer you have to get is 18 volts. So having completed on the discussion of numerical problems related to Ohm's law and Kirchhoff's law, now you should be able to determine branch currents and voltages. Power is asked means what you will do? Power is equal to voltage into current. Okay. Of DC, simple DC circuits using Ohm's law and Kirchhoff's laws. For further understanding, refer this textbook K. Umarov, Basic Electrical Engineering, and you can refer for this topic chapter 1, examples 1.5 to 1.20 listed here. Thank you, students.